I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss congruent triangles. It is a test review with grade 8 student doing grade 10 mathematics. Recall the concepts which are applied in solving examination style questions and discover new strategies. I'll provide you with short answers. The idea is for you to pause the videos and answer the questions completely. We'll also extend this video to 3D applications as the student wants to know about it. Our approach, engaging minds. Connect with context, visualize strategy, apply learnings, bridge the gaps. So, in this session of about half an hour, we are covering two topics which student wants to review before the test. Gain confidence and get ready for future. That is our approach to develop mathematical and social skills. Go with the confidence you need for your exam. Gift of education. I can be part of your success story, build strong foundation, ensure bright future. Contact me on the email address given and join my classes to know more. Let's now enjoy the lesson with the student Abhinav. Hi Abhinav, how are you doing?
I'm good. How are you?
Very good, very good. So today, what do you want to learn?
On the concept of proving how different triangles are similar.
Okay. Congruent and similar triangles, you mean, right?
Yeah.
Okay, great. So why don't you share and then we'll discuss the questions which you have.
Yeah. Okay.
Oh, that's the first question. Very beautiful.
Yeah.
So can you please read the question?
Okay. Given segment DA is congruent to segment CB, angle DAB is congruent to angle CBA. Prove that triangle AOB is isosceles.
AOB, the smaller one, is an isosceles. So we have to see this side is equal to that side. Correct, correct, correct. Okay. So from the bigger triangle which is given to us, we are looking into the triangle ADB. And because this angle A is equal, ADB, and triangle BCA, we have in these two triangles common angle, right? So angle A is equals to angle B, correct? So one of the angles is common. The side is also equal. So we have DA equals to CB. You have to write conditions here, right? So it is given. And then we have AB as common.
Yeah.
Reflexive. It is reflexive. So we have these two congruent triangles. Since the triangles are congruent, all their angles should be equal. So this angle is equal to the other angle, correct?
Yeah.
So those angles are equal. We have to, however, show that, and we know this longer side is also equal, right? So longer side is equal. Now we have to show that the triangle AOB is isosceles. That means these two sides are equal. So we'll go in for the smaller triangles, which are triangle AOD and BOC, correct?
Yeah.
So in triangle AOD and BOC, we notice that we have same angles on the top, the same sides, correct?
Yeah.
And we just showed that these triangles are congruent. That means we have a nice so when you have angle, and side, the third angle will also be equal, correct? Because of the 180 degrees, correct?
Yeah.
So we have angle, side angle,
Yeah.
and therefore those are congruent triangles. Since they are congruent triangles, these sides will be equal. Is it okay?
Yeah.
So that is how we are going to prove this particular uh, triangle is isosceles, correct?
Yeah.
Let's move on and take the next question.
Okay.
Can you please read the question?
Given segment DA is perpendicular to segment AB, segment CB is perpendicular to segment BA,
Correct.
angle CAB is congruent to angle DBA. Prove that angle D is congruent to angle C.
So we are given all this. Now, in a right angle triangle, you can use hypotenuse leg theorem.
Yeah.
Now, here we have a common base. Do you see that?
Yeah.
So, so we have a common base, and since these angles are equal with a common base, the second side will be equal and hypotenuse will also be equal. Is it okay?
Yeah.
And using the hypotenuse leg theorem, those two triangles are congruent. And since
Yeah.
they are congruent, the angle D will be equal to angle C, correct?
Yeah.
Yeah, next question.
Okay. Given segment TM is congruent to segment TN, angle TRS is congruent to angle TSR. Prove that triangle RTN is congruent to triangle STN.
R, RTN, the smaller triangle, right? Okay.
Yeah.
Is congruent to STM. Okay. So we are given that these two base angles are equal. That means they are isosceles triangles, right?
Yeah.
So these two sides are congruent, correct?
Yeah.
Since those two sides, longer sides are congruent, we can show that the tri and we know this is given to us as these are equal. That means these are also
Yeah.
equal, correct?
Yeah.
Now we have a common base and angle given and these two equal sides. So from SAS, the two triangles are congruent. Is it clear?
Yeah.
That's how we are going to do it.
Given triangle GRE is congruent to triangle SRT, prove that triangle SEN is congruent to triangle GTN.
Okay, so we are given these small triangles as congruent. Let me just shade there. This one and this one, right?
Yeah.
So when they are congruent triangles, we can say that this side is equal to this side, that side is equal to that side, and the angle, most important for the bigger triangle, is also equal. Is that clear to you?
Yeah.
And this angle is also equal. Correct? Now,
Yeah.
if that angle is equal, we are looking into the bigger triangles which we need to prove. That means this angle, which is 180 minus that, will be equal to that angle, correct?
Yeah.
So when you go for the triangle SEN, big triangle, okay, SEEN, then this angle is equal to GTN. So GTN is equal to that angle. So we have identified these two as equal angles, correct?
Yeah.
And we already know that these two sides were equal corresponding. So therefore, the length SE is equal to GT, right?
Yeah.
So we have these two sides also equal, and the angle N is common, correct? So from
Yeah.
AAS, now AAS can work because the other angles are also equal, right? So you can say that these two triangles are now congruent. Is it okay?
Yeah.
Yeah.
Given angle CDB is congruent to angle CEA, segment CA is congruent to segment CB, segment AD is congruent to segment BE. Prove prove that segment AE is congruent to segment BD.
Okay. So since we are given that segment CA is congruent to segment CB, that means this is an isosceles triangle, right?
Yeah,
So that means this angle is equal to that angle, correct?
yeah,
We have to show that angle side AE is congruent to BD. So if you look into that particular big small triangles which we are looking into, right? We have a common base. We have two equal angles, correct?
yeah,
And we have this side also equal, correct? And therefore they are congruent triangles. And so we can say that AE is equals to DB, correct?
yeah,
So to prove, when you write the proof, you have to write condition here, right? Remarks. So whatever statements you are giving, provide conditions for those. Is it okay? So write in
yeah,
proper format to get your result. I think that should be okay. Is that clear to your solution?
yeah.
Okay. Any other question?
No,
Okay, so these were actually pretty good questions. We went quickly through them. However,
yeah,
I'd like you to go slowly through them, write each condition. This is given, this is reflexive, this is because of the congruency property, SSS, SAS, or whatever. And then
mhm,
from there, you conclude the result. So that is how you could do it. And in some class, especially question number one, and even the last question, we had to solve the triangle twice for congruency, right?
yeah,
So sometimes you might have to do it. So they were very tricky questions actually. So I like you to do them on your own and see how to actually do it in the test paper. Is that clear?
yeah.
Right. So anything else you want to share on this
No,
or any other topic?
yeah. I think like angle of elevation and depression is also a little confusing.
Okay, sure.
Like what?
Angle of elevation. So you mean trigonometry part or
Yeah.
trigonometry? Okay. So we can look into angle of elevation and depression.
Okay.
Let me share a whiteboard. So normally in applications, basically, let us say this is the ground. We'll consider ground to be horizontal, even, correct?
Yeah.
Always in our examples. And let us consider a tree here. Okay. Let's say we have a tree here. So if you're looking from some distance, let us say from here, then this angle is called angle of elevation. So that is your angle of elevation.
Yeah.
So I'll take a question based on angle of elevation. So let us
Mhm.
say the angle of elevation for us is 30 degrees. Let me make it equal to 30 degrees. Let's take a simple question, right?
Okay.
And then let's say we covered another distance and now the angle of elevation becomes 60 degrees after covering a distance of, let's say, 20 meters. Now the question is, find the height of the tree. Now this is also a way of finding height of the tree or any monument or any building or whatever. Correct? So what you could
Yeah.
do is you can measure the angle of elevation from a point, walk some, let's say 100 meters, whatever distance, and then again measure the angle of elevation. So you can now find the height of the tree, correct? So in this particular example, can you tell me what is the height of the tree and how will you do it?
Okay.
So let's say this position is x, which we don't know.
Yeah.
And what we know is simple trigonometry, right angle trigonometry.
Yeah.
We could use other ways where we understand that sine is the ratio of opposite over hypotenuse, cosine is the ratio of adjacent over hypotenuse, and tan is the ratio of opposite over adjacent. Is that clear to you?
Yeah.
Now, since we are talking about something which involves height and adjacent side, so we'll use tangent ratio, right?
Yeah.
So we can write tan of 30 degrees is equal to the height h over total distance, which is 20 plus x.
Yeah.
Well, to find tan 30 degrees, you can use calculator or you can also use a special triangle. So I'm just drawing a special triangle for you here. 60, 30, 90 degrees triangle.
Okay.
The ratios are 1, 2, square root 3, right?
Yeah.
We get this because if I have an equilateral triangle, each side will be 2 units perpendicular, bisector. Well, bisected into two triangles, 30, 60, 90 each. So half of 2 is 1 and square root 3 is 2 square minus 1 square, correct? 4 minus 1, 3 square. So from here, you know tan of 30 is half, correct?
Yeah.
Oh, sorry, 1 over square root 3. So you can cross multiply, you get 20 plus x is equals to square root 3h, right?
Yeah.
So we have one equation. Now let's look into the smaller triangle, this one. Let me use a different ink this time. So what is tan of 60? Is h over x, right?
Yeah.
And now tan of 60 is square root 3. So we have square root 3 equals to h over x. Or we can say that in this case, x is equals to h over square root 3, correct?
Yeah.
So we need to find h. So let's substitute the value of x here in the first equation. So we have 20 plus h over square root 3 equals to square root 3h. Is that okay?
Yeah.
Multiply by square root 3 to simplify. So we get 20 square root 3 plus h equals to 3h. Correct?
Yeah.
And then you solve this equation. So we get 20 square root 3 equals to 3h minus h, which is 2h. And that gives you the value of h as 20 square root 3 over 2 or 10 square root 3. Correct?
Yeah.
So we quickly found the height of the tree using just tangent ratio, right? Now, this is a straightforward method. We could have adopted many other methods to find this, but solving two triangles, we could get it. And that is how you will do it, okay? Units, of course, meters.
Okay.
So now let me take another example, which will be based on angle of depression. This was angle of elevation, right?
Yeah.
Angle of depression, uh, let's consider, let's say there is sun somewhere, right? So when there is a sun, there will be shadow. So let us say
Yeah.
there is shadow and we know that some object is this much tall and the shadow is kind of like this. Now we can say that the angle of depression from this particular point is, let's say, 40 degrees.
Okay.
So the angle with the horizontal. So what is the depression, angle of depression? It is always with the horizontal, right? So
Yeah.
from horizontal. In the previous case also, angle of elevation was also from horizontal. Do you see that? And now
Yeah.
remember this thing, these two are considered horizontal lines, so they are parallel, right?
Yeah.
And you know it forms a Z pattern, so it is also equals to 40 degrees. So what do you see most of the time, all the time, that angle of depression is actually equals to angle of elevation. Do you see that now?
Yeah.
We may call them in a different name only because it makes sense, right? Elevation means looking upwards, depression looking downwards, correct?
Yeah.
So that is the kind of case, and we can, in this particular fashion, if I know the angle of depression, and let's say if we know what is the length of the shadow, let's say length of this shadow is 100 meters, we can find the height, correct?
Yeah.
Very simple. So using in this again tangent ratio, which is 40 degrees, is height over 100, correct? So
Yeah.
height is equals to 100 tan 40 degrees. In this case, we can use a calculator to find what tan 40 degrees is, multiply by 100, write down our units in meters. Is that clear to you?
Yeah.
So that is how we could actually solve a question based on angle of elevation and angle of depression.
Okay.
Now, we could have very difficult questions based on angle of depression and angle of elevation if you look into 3D figures. If you understand, so I'll just make one here, right?
Okay.
So let us, whenever you have a 3D picture, in that case, let's think like this: somebody is, this is a bridge. Okay, let's say this is a bridge, and it is 50 meet. Let's say 50. What should I? 50 feet high.
Okay.
Now, so we're considering this to be north for now, and then we're saying that the angle of some at from this point you observe two boats, let's say, right?
Okay.
And we could say that let the angle of depression from here for boat A, let's call this as boat A and B.
Okay.
And we're saying that angle of depression means this is C. It is kind of angle of depression is, let's say, 30 degrees, right? From here, angle of depression is 30 degrees. How will you draw it? So you have to draw a line parallel to the base. Is that okay?
Yeah.
And from here, the angle of depression is, let's say, this is your angle of depression. Let's say this angle is 20 degrees. Is it okay?
Yeah.
And on this side, the angle of depression is, let us say, let me just first draw and then I'll put a value. Is it okay?
Yeah.
Now this is, when we're talking about the angle of depression on this side, so we have to draw a line parallel to this. That becomes the angle of depression. You see that?
Yeah.
Let's say this angle is 10 degrees. We know the height, correct?
Yeah.
Now, in these kind of questions, we have to find the distance between the boat, for example. Okay. We need to find what is the distance between the boats. Is it okay? Let us
Yeah.
assume, make it very simple, that from north, this direction here is towards the west and this is east.
Okay.
Uh, so let's say this is perpendicular. I could have given some other angle also, but I'm making it simple now. Okay.
Okay.
So once you know this angle, you can actually find the distance from the foot of the bridge, correct? Using tan, because this is also 20 degrees and this is here 10 degrees, correct?
Yeah.
We know the height. So we know that, let's say this is O. So we know OA, we can find ratio OA. Let me write down in proper way. So tan 20 degrees will be equals to 50 meters, which is the height, divided by OA, right? And therefore, OA is 50 over tan 20 degrees. Perfect.
Yeah.
Similarly, OB will be equals to 50 over tan of 10 degrees because this angle is 10 degrees.
Yeah.
Once you know OA and OB, since we know the angle in the center is 90 degrees, it is right angle triangle. So we know that A to B is basically equal to what? Let's say, let me write square, is 50 over tan 20 degrees. square plus 50 over 10, 10 degrees. Is it okay? So we'll square root and find the value of AB, correct?
Yeah.
So from here, you actually get a general formula. You realize?
Yeah.
If I say generally the height is h, right? And this is alpha and this is beta, is it okay?
Yeah.
Then we know what AB is. So AB in general is equal to square root of height h over tan of alpha, right? Square, correct?
Yeah.
Plus h over tan of beta square root. You see that? So
Yeah.
all of a sudden, if we understand this picture very well, we have a general formula here, correct? Given the
Yeah.
value of angle of depression from the point, which is h meters above the water level, it could be sea or it could be a lake or ocean or whatever, right? We can easily find the distance between the two boats, right? And
Yeah.
of course, if this angle is not 90 degrees, let us say this angle is theta, then we can use cosine law. Correct? So since you have not done cosine law yet, I took that angle as 90 degrees to solve it. Is that clear to you?
Yeah.
So that is how we could solve a 3D question where we have angle of elevation or angle of depression and similar things. Is that okay?
Yeah.
Perfect. So did you understand all this concept?
Yeah.
Perfect. So here, this is a very important question. How do you sketch a 3D figure? That is what I've shown you. I could have given you angles in many different ways. I could have given you angle as in a bearing angle form, right? Or
Yeah.
from north and east, all those complications. But in simplified form, that becomes the base of solving 3D figures or questions, applications in this fashion. Is that clear? So it really works for many complicated questions, this method. So let me end the class now. I'd like you to share your learnings today. So Abhinav, what did you learn today?
So we first proved similarity in congruent triangles,
Correct.
congruence and similarity using proofs and different theorems. And then we explored on angle of depression and elevation and real life 3D world examples and how to find them. And we learned a general formula.
Very good, very good. So basically, when we are talking about congruent triangles, we should not be using the term similarity. Okay.
Okay.
Similar means there is a scale factor in the two triangles. They have all the three angles equal, so one could be bigger than the other, right? Similar triangles are not congruent. Similar triangles can be congruent if one of their sides, corresponding side is equal. Is that okay?
Yeah.
So in general, no. So if one of the sides is congruent, then they are congruent. Therefore, we avoid the term similar when we talk about congruent triangles. Okay, keep
Okay.
that in mind. So use the word congruent, congruent, or equal. That will be good.
Okay.
Perfect. So we'll end the class here. See you next time. Okay, then. All the best. Gift of education. I can be part of your success story. Build strong foundation, ensure bright future. Connect with Anil Kumar classes. Thanks and all the best.